everyone. We'll be starting right now. What's up? Alright. Hey everyone, I'm Johnathan, and today I'll be doing a Unity demo. So for those who don't know, what is Unity and why do we use it? So Unity is a powerful and versatile game development platform that allows creators to build high-quality interactive experiences for various. Okay. Yeah, we're gonna start, or we started already. All right. Everyone, I'm Johnathan. I'll be doing a Unity demo today. So what is Unity and why do we use it? For those who don't know, Unity is a powerful and versatile game development platform that allows creators to build high-quality interactive experiences for various platforms, including mobile devices, consoles, and PCs. So why use it? Well, it's free, it's easy to learn, and it has lots of tutorials and forums for help. For installation and setup, I prefer using the I recommend using Visual Studios for our IDE. Other IDEs such as VS Code can be used, but they may be less user-friendly. And obviously, the other software that we'll be needing to use would be Unity Game Engine, which will be downloaded in unity.com. Alright, so what we will be doing today, we will be setting up a virtual camera, and we'll create a third-person player movement that involves movements and jump. Alright, that being said, let's get down to the demo. So once you complete the installation, you should have two softwares right here. Oh, you can't see it. Okay. And there's going to be a Unity Hub software and a Visual Studio software. Unfortunately, you can't see it in the bottom of the dock, but yeah, it's right there. Yeah, but once you click, you should click Unity Hub. Once you click it, this is what the screen will look like. There will be, there are existing projects right here that are displayed. For us, if you're creating a new project, you'll click on this blue button right here. And this is how you create your Unity project. There are various platforms that you can build upon. You can do a 2D game. A 3D game, you can even include URPs right over here, or even mobile games. If you don't know, URP stands for Universal Render Pipeline, which involves with special effects and glow effects. Now, for the sake of the demo, I'll be opening up an existing project. So this project hasn't been touched. If you open up, if you create a new project, this will be what you will see. You'll have two game objects right here, a main camera and a directional light. You'll have a scene view where you can modify your game object's composition. Now, for the sake of the tutorial, I'm going to create a game object. I'm going to go right click, I'm going to go 3D object, and I'm going to create a capsule right here. Alright, once I create a capsule, this will be the graphics for our player. So I'm going to call this graphics for now. And because this is going to be for graphics, I'm going to remove the collider right here. And what I'm going to do is I'm going to create a new empty game object. I'm going to call it player. I'm going to drag that graphics right in there. Just reset that real quick. And there you have it. So once I did that, as you can see, if I click on the player game object, if I drag it around, since the graphics is a child of this game object, it should move along with it. Now, since there's no visual indicator of which direction this graphics is facing, I'm going to also create a new, another 3D object. It's a cube. And what I'm going to do is that I'm going to go over here. This is the transform variable. I'm going to go to the position, and I'm going to move the z-axis forward. So now it's facing forward. And I can just scale this up right here. There you have it. Let me just remove this real quick. There you go. And that would be the visual for the player. So let's see. In order to create the movements for a player, you will need a character controller. So this is where you add components. We will be using the character controller. We will also be creating a script called player movements. Right here. And once we right-click, we click Edit Script. It's gonna open up a Visual Studio. You might not be able to see it. There you go. So it'll automatically open your IDE for Visual Studios. And it'll automatically it'll show this template right here. So what this basically means is that the start function starts at the beginning of the game, and the update function starts at every frame, or it continues on. It runs every frame during the game. So before we do that, let's go with let's start creating the virtual camera first. Since we are making a third-person player, we do need a virtual camera. In order to create a virtual camera, you need to use Cinemachine. In order to do that, you have to go to Windows, Package Manager. Go to the Unity registry right here. You can type Cinemachine, and you can download it right here. Once you have that done, you can right-click. What's up? And then everything's settled. Just for visuals for today, I'll just create a 3D object. I'll create a terrain right here. So 3D object terrain. Then I'm gonna scale this to -500, since this thing is scaled by 1,000. The terrain, just to have it centered. I'm just gonna drag the player up a little bit, just to make it more visually appealing. Alright. And now we can work on the virtual camera. So in order to add a virtual camera, I'm gonna click Cinemachine and free look camera right here. Once I created a free look camera, you can see it looks a little gnarly, but all you have to do is to drag this player into the follow. So the camera is constantly following the player, and dragging the player to the look at area. So the camera is also looking at the camera. Now you can see that there are like red lines over there. That is an indicator of where your camera is going to move towards. So you can adjust this accordingly so that you can have it positioned to how you want it to be. So if you run it, you can move around and see like that. Alright, now that the camera is complete, we can work on the player movements. Hold on. Alright. Now that we have the character movements ready, what we need in the script for movements, what we basically need for now, there's a character controller that we need to access to. So what we have to do is public character controller, and let's name it player control. We'll also need public float speed in order to control the speed of the player movements. Let's say. What's up? Alright, perfect. Alright, now we will have to add inputs for the player movements. For that, we can do float horizontal. To get the horizontal movement, it's G#.
Well, can you show me again how to make a script?
Which part?
How to make a script for something?
How to make a script? You click on add component, and you just name the script, like player movement, for example, and then you just
a script.
Yeah,
okay.
just create a script right there. All right, input get access raw. This is verbatim. You write horizontal. So this will access the left and arrow key as well as the AD key. basically the left and right movements. And likewise, we can do the up and down keys, the W and S key, through vertical. There we go. And with that, we do need a direction in order to capture it. And here we can just put in the horizontal and vertical movements likewise. Just like that. And then we can do if... Oh, we gotta normalize it too. There we go. Now all we have to do is if the direction is greater than or equal to 0.1 f. So if the player presses any keys, then we'll move. What we can do is that now we need movements, so we need to access player control. And what we do is we do dot move, and we put the direction inside, we multiply it by the speed, we time it by time.delta time, so that moves with respect to the frames. Alright, and make sure that this is in magnitude, because we're checking the magnitude of the direction. Alright. Alright, with this, if I added speed right here, and just make sure you gotta drag the character controller inside the player controller right here. With that, if I run it, it's gonna move. Now you'll notice that while it's moving, it's not facing towards the direction that I want to face towards, that it should be facing towards. So we can add the rotation of the player object, respectively. And to do that, all we have to do is type float, target angle. And this might be a little gnarly, but if you remember it, it should be good. It should be good. All you have to do is use ATAN2. Have it be revolve around the X and Z direction, X and Z axis of the direction. And we gotta time it. We gotta time it by rad to degree because it is in radians. Nope. Alright, and then now we have to reference it back to the transform variable. So we do transform.rotation equals Quaternion.Euler. This is how we set the transform rotations using Quaternion Euler. We do 0, and we're using the y-axis to rotate the player. So we're going to put the target angle in the y-axis area right here. And with that, if I do this, now it's facing towards the direction I want it to move. Now while it's facing towards the direction I want to move, it's not too smooth. So what we can do is that we can smoothen the angle, and to do that, it's very simple. All we have to do create a float smooth angle to math.dampen smooth dampen angle, so that we want to dampen that angle. And what we have to do is we do transform dot the Euler angles, the angle of the game object itself in accordance to its y-axis, and the target angle itself. And then what we need, it might be a little gnarly, but we will need a reference. And you don't have to worry too much about the reference, since...
I'm just trying to see what he's doing.
Oh. just for the function. And what we can do is that we can add a float, public float, smooth angle, or smooth time, so that we can control the smoothness of the time. We do a smooth angle, replace the target angle with a smooth angle. And once you do that, you can see a smooth time right here. We can set it to 1.5, just like so. And there you go, that's it.